function is nothing more than e. So that's what you need to remember. So far we've done natural logarithmic function, which is ln, and the natural exponential function, which is le. The inverse of the natural logarithmic function is called the natural exponential function and is denoted by f inverse of x equals e to the x. So they're inverses, and on your calculator you're going to notice that they actually share the same button over here by the number 4. So that's kind of one of those things. If you notice that a button is shared with another one, they're probably inverses. Just like the square root and the squared, just like the 10 to the x and the logarithm, just like the sine and inverse sine. Those are all inverses, and so that's kind of a little trick that you can use to figure out if they're inverses. And then the biggest thing I want you to take from this is y equals e to the x if and only if x equals natural log of y. And it's one of those things that you don't necessarily need to remember because you can derive. If I start with y equals e to the x, I know that its inverse is natural log. So if I take the natural log of both sides, okay, on the left I get natural log of y. On the right, natural log and e, since they're inverses, they cancel out, and that leaves me with the x. So it's something that you don't necessarily need to memorize. And so inverse relationship, if you notice down there in the blue box, that is real similar to what we just looked at. And remember, natural log and e, they cancel each other out. So that's why that equals x. E and ln, they cancel each other out. That's why it equals x.
It doesn't matter where it's at, they always cancel.
Right. They have to be next to each other. Okay. All right, so we're just going to solve some basic equations today. I think we'll get to derivatives as well, but we're going to hold off on the integrals for a later time. So it just says to solve this equation. So I see x is in the exponent, and so I'm going to get rid of the e. So in order to get rid of the e, I'm just going to take the natural log of both sides. And when I do that, on the left I get natural log of 7. On the right I get x plus 1. Okay, now the biggest thing you need to understand, okay, obviously when we solve this we're going to subtract 1. This is not the natural log of 6. Okay, this is not the natural log of 6. What you need to do is actually calculate the natural log of 7, whatever it is, and then subtract the whole number 1, and then that will be your value of x. So let's go ahead and find that to 2 decimal places.
1.95, 2 decimal places?
Yeah.
95.
And that was with the minus 1?
No, minus 1.
0.95.
So the answer is actually 0.95 when you subtract the 1. Okay. So pretty straightforward. All right, let's look at another one. Okay, natural log of 2x minus 3 equals 5. So what are you going to do?
Eat it up.
Yep. So I'm going to take the natural exponential function, or e, to both sides. On the left side, what ends up happening is the e and the ln cancel, and that leaves me with 2x minus 3. No, you don't need to put parentheses. In fact, I wish I probably wouldn't have even written them. And so I have equals e to the 5th. So in order to solve this, the first thing I'm going to do is add 3. So I end up getting e to the 5th plus 3. And then the last thing I'm going to do to solve is divide by 2. Okay. So once again, if we wanted a decimal approximation, you're going to do e caret 5. Add 3, get an answer, and then divide that all by 2. Somebody else get that? Yep. Okay. There you go. So pretty straightforward. Okay. So now, this is a review. I don't know if you necessarily need to write this down. With exponents, if you have the same bases, remember we add the exponents. The same holds true for e. Same thing here, if you divide with e, you subtract the exponents. A little bit about the properties, and we could get this when we graph. The domain is negative infinity to positive infinity, and the range is from 0 to infinity. And like I said, if we would graph that, you would see that the function is continuous, increasing, and 1 to 1. And it's also concave upward. So concave upward means it
It's a bowl.
bowl, holds water. Okay, the limit as it approaches negative infinity is 0, and as it approaches positive infinity will be positive infinity. And that should make sense because it's increasing. So it's going to increase without bound. And like I said, if we graphed that, you could see all of those things. And so now we're going to talk about the derivative of e, and this is where we're going to end today after we go through a few examples. The derivative is actually very easy. The biggest thing you need to understand is that the derivative of e to the u is just e to the u times du. E to the u times du. So find the derivative. That's the very first one we're going to look at. Y equals e to the 2x minus 1. So what would u be in that problem? 2x minus 1. What's the derivative of 2x minus 1? 2. So what they're saying the derivative is, it's just going to be e to the 2x minus 1, that's e to the u, times du. And yes, we do need to simplify that a little bit. You need to put the 2 in front. So your derivative is just 2e to the 2x minus 1. Now, on these problems, you're probably not even going to need to identify u and du. You could probably just look at this and figure it out. Okay? Because basically it's nothing more than the derivative of this times the original function. Okay? Derivative of 2x minus 1 is 2, and then I take it times the original function. Okay? Pretty straightforward. So now the next one, however, the derivative isn't as easy. Okay, we need to go back and remember how we find that derivative. So, what would the derivative of negative 3 over x be?
Negative 3x.
Okay, so that's really what negative 3 over x is, right? So the derivative is 3x to the negative 2 power, which is really,
You subtract the reverse.
with derivatives you subtract, with integrals you add. And then e to the negative 3 over x. So far, so good? Okay. I have the next slide. Okay, so right now, this is your whole assignment for the whole section. Okay, we haven't covered the whole section yet. Okay, but this will get you started. Okay, we haven't covered the whole section, especially this 85 to 95 and the 99 to 104. This is with integrals, and we haven't covered the integrals yet. So Monday, remember, you're going to have a quiz. I'm not going to be here, and so you'll probably have, I don't know if it'll be a longer quiz, but it'll be over section 5.3 and 5.2 and 5.1.